Totally. So, hello, can.
Okay, your instructor is taking over now. Yes, can you hear me?
Yes, I sent your number to some people. They said they want to pay. So I said once they pay, they should charge you up.
Okay. Alright. The class is starting now. Your instructor is taking over.
Okay.
I'll just be moderating.
Okay, I should hear you, right?
Yes, you can mute. If you have questions, you can ask.
Alright, thank you.
Alright.
So I should unmute, right? Hello, madam. Hello.
You can unmute.
Hello. Hello, madam. Mrs. Alima. Hello. Yeah. Good morning. Good morning, ma. How are you and everyone? I'm okay. So I'll be the one to be taking you this course, Maths 101, which is elementary math. Can you hear me? Can you hear me? Can you hear me? Can you hear me?
Yes,
Oh, okay. I'm the one to be taking you this course. It's elementary mathematics 1. Okay? All right, I can hear you too. So we are looking at this course, elementary mathematics 1. Okay? So I'm going to go through the course material. I'll go through the course material and... Okay. So I will go through the scheme of work. Okay. So we'll go through the scheme of work and we'll know what we'll be doing, so that you can follow up from beginning to the end down to your exams. Okay. So I want to go through. Okay. So I want to go through the course content before we commence. So if you look at module 1, we have unit commence. So if you look at module 1, we have unit 1, which is elementary set theory, basic set operations, and sets of numbers. Then in unit 1, we have introduction, sets, notation in set, finite and infinite set, equality of set, non-set, proper subset, comparability, set of sets, universal set, power of set, disjoint set. We have Venn linear diagram, axiomatic development of set theory, then conclusion. That is module 1. Then go to okay. Then we go to module 2. We have sequence and series. So this course, sequence and series, talking about AP and GP. But that is what I'm using. Okay. Yes. That's what I'm using. Okay, so so module 3, like I said, is complex numbers and circular measurements. So we're going to start with the first one, which is this now. I started with this one, which is module 1. We're starting with this. You are not saying it. Are you saying it? You are not saying it. Okay. No, hold on. It's showing, maybe probably your network. It's showing. It's probably your network. Hello? You are not saying it. Okay. Are you seeing what I'm writing? Okay. You are still not saying it. Okay. Okay, so we are looking at set theory. That's the first topic we are looking at, set theory. I believe you must have heard when people say, I went to buy set of plates, set of spoon, set of cups, and the rest, right? In the market, where people say, I want to buy set of spoon, set of plates, set of pots, set of cups, and the rest. Have you heard that before? look at some basic terms they use in sets. There are some basic terminology they use in sets. Yes. So we're going to start with the definition, then we move. Set theory, yes, that's elementary set theory. So we're going to define sets. So I don't know if you say you're not seeing my board. So I want to define sets as. You say you're not seeing my board. So I want to define sets as. Set is defined as the collection. Okay. Set is defined as a collection of distinct objects or items. So you can write it down. Set is defined as the collection of distinct objects, distinct. So you can write them down. Example include set of spoon, set of pots, set of plates, and set of plates. Okay, set of cups. So those are examples of sets. Okay. Are you there? Okay. So when they say something is distinct, what does that mean? Yes. Those are examples of sets. So set is a collection of distinct objects. Okay. So let's understand the word distinct. What does distinct mean in set? Okay. So I was trying to say, what does distinct mean? When you say something is a distinct object, okay, what does it mean? So when you say something is distinct, it means they are unique, it has no repetition. This to me, they are sets of, these are elements in a set, normally listed only once, no repetition. That is what we mean by distinct. Elements in a set, listed only once, without repetition. That's what we mean by distinct. Elements in a set, listed only once, without repetition. Okay? Hello? Okay. I said distinct mean, the word distinct means element in a set. Hello, distinct mean element in a set repeated only once without repetition or duplicate. That's what I mean by distinct. I don't know if you can please write it down. Please write it down. I said in a set repeated once without duplication or repetition. And that's what I mean by distinct. Okay? That's what I mean by distinct. Yes. So when I say set is a collection of distinct objects, means those objects, they are just ones. You don't have to repeat it. I cannot say so so you cannot have things like for instance now I cannot have spoon, plate, then spoon again. Are you saying it? You cannot have plate, spoon, then another plate. So it should just be plate, spoon, here just once. That's what I mean by distinct objects. Just once. Yes. So next we are going to representation of sets. Representation of sets. How do we represent sets? How do we representation of sets as a new topic, a new subtopic? Representation of sets. Okay? Representation of sets. So sets are usually represented in capital letter. That's how you represent sets. If I want to say a set of spoon, I will represent it with capital letter. Sets are usually represented in capital letter. That's how you represent sets. For instance, you can have set a capital letter, then you put the set of items. Then you can also have set B. You also put the set of items under set B. So sets are usually denoted in capital letter. Okay? Yes. So if you go for any set, you see, they want to give you any set, that set will be represented in capital. They do not give you the set of things that is there. But the set itself is represented in capital letter. Okay? Alright, so next is set notation. These are just the concepts. You need to know this concept before you can solve any question in them. You need to understand all these concepts before you can solve any question in them. Okay? So we have set notation. Set notation. How do you know that it's a set and not just a bracket? We have what we call set notation. Are you saying you are not seeing my board? Are you not seeing the board? Okay, all right. Are you seeing the board now? Are you seeing the board? Okay, so thank you. So we are going to set notation. How do we notify set? How do we show that it's a set? Okay. How do we show that it is a set? So sets are usually notified using a particular symbol. Okay. So this is so the set notation is given as the set notation is given as, so this is how you identify set. This is how it's written. So you don't write set like this, not like this. You don't do it like this. Are you seeing the difference? Yes, this is how you identify sets with this sign here, not this. So anytime you see a thing like this, you just know that they're talking about a set. Yes. So that will take us to type of sets. That will take us to types of sets. Types of sets. Okay. Types of sets. So the first type of set we have what we call finite. Finite. We have what we call finite sets. Finite sets. So what are these finite sets? These are countable sets. These are countable. Things you can count. These are things you can count. Countable sets. For instance, can you give me an example of things you can count? Example. Exactly. Those are examples of countable sets. Examples is a set of shares. Set of shares is an example of a countable set. You can easily count shares, right? Then have you written it? Then the second one we have number 2, infinite sets. Infinite sets, yes. What are the infinite sets? These are uncountable. These are uncountable sets, meaning you can't count it. Exactly. These are uncountable numbers of elements. Uncountable numbers of elements. You just gave a very good example now. We have things like you have things like rice, sand, water, and so these are examples of infinite sets. So you can write any of those things as your example. You can write any of those as your example. Okay. Then number 3, we have what we call empty sets. Empty sets. This empty set has another name. They call it a null set. That's another name for it. They call it null set. Yes. It's not there. It's empty. It's empty. Yes. So these are sets containing no elements. These are sets containing no element at all. It doesn't have any element at all. I will call, yes, containing no elements or objects. I will call non-sets. Okay? Are you there? So this size, it has a symbol. It is donated as. How do you know it's an empty set? So this is a symbol for it. This is a symbol to donate it. That is symbol for empty set. Or you just see the set with no element inside, just like this. There's no element inside. That's how you donate. Yes, that's how you donate an empty set. So when you see anytime you see a symbol like this, either this or this, it means that it represents what? An empty set. Yes. Or what's the other name for empty set? It's a non-set. Yes. Meaning a set with no elements or objects. That's what we call empty set. And what you want to note from here is a symbol for it. the symbol for empty set and the definition of empty set is very important. So it's not all the time they call it empty set. Sometimes they call it a non-set. Please pay attention to those details. So all these things are very important. It's good for you to have all this knowledge before we start taking questions from them. Okay. Yeah. Then number 4, we have what we call universal set. Universal set. Universal set. Universal set. This universal set has a symbol too. This is how the symbol. This is how it is written. They write it like this, or it's written like this. So enter a symbol like this. No, it's a universal set. So this topic is all about symbols. The symbols are very important. It's all about symbols. Okay. So the universal set is a set. That contains all the elements of a set. That contain all the elements of a set. Yes. Please, what is important here, take note of the symbols. The symbols are very important. They are very, very important, yes. That's one. So that is symbol for universal set, and that is definition of a universal set. So like I said, without all this knowledge, we cannot solve a single question on that set. So you are going to need all this knowledge to be able to successfully solve questions without an issue. Okay, is it understood? And that is the symbol for, like I said, the topic is all about symbols. So take note of this. We are going to see something like this. And we are going to see something like this later, but not exactly like this. That is why you should take note of what you are saying. We are going to see something like this later, but not exactly like this. What I just said now with the yellow ink. Take note of that. Yeah. Then number 1 we have, number 5 we have what we call subsets. Yes, subsets. So if I have two sets right now, maybe I have two sets, set A, then B. Let's assume we have two sets A and B. Okay. You can see this sign I put here. You see this sign? That is the sign for subset. That is the symbol for subset. Yes, that is the symbol for subset. Okay. So this one means that A is a subset. Is a subset of B. That's what it means. Are you saying it? That statement, this statement here means that A is a subset of B. Yes. That's what the statement means. A is a subset of B. But what does it actually mean in practical sense? What does it actually mean in practical sense? What it means is that it means that every element in set A can be found. Every element in set here can be found in set B. Every element in set A can be found in set B. So this one means that every element in set A can be found in B, can be found. I'm going to give you a typical example now. Can be found in B. Every element in set A can be found in B. Are you there? Okay, let me give you a typical example of what I mean by that. Let's assume this is set A. Set A, now I told you set is already represented in what? In capital letter. So let's say set A is 1, 2, 3, and 4, for instance. Then set B is 2 and 4. Are you saying it? So if you look at B, what are the elements in B? Can you mention the elements in B? Now that 2 and 4, can you find that 2 and 4 in A? Can you see that 2 and 4 in A? Yeah, it's present in A, right? So it therefore means that yes, it's present in A, right? So this one means that B is a subset of A, meaning B is part of A. I can see all what B have in A, so B is a subset of A. Is it understood? Okay, all right. So that's the concept of a subset. So we also have what we call number 5. What was also called proper sets. Proper set. It's another type of set. Proper set. This is how it's written. A is a proper set of B. So you can see the difference, the subset and the proper set. So can you tell me the difference between the subset and the proper set? In terms of their representation, how do we represent subset? Yes. Exactly. Does it? Exactly. So that's what I mean by a subset. So if A, for instance, A is a subset of B, but A is not equal to B. Okay, that's what I mean. Yes. So a typical example is this. A typical example is when you have, maybe I have as we have B as 2, 4, 6, 8, and we have A as is 4, 6, and what? And 8. Are you seeing it? So there's what is different between the two sets now? Yes. It doesn't have the 2. Are you getting it? So that means that A is a proper set of B. Okay, that's what it means. A is a proper set of B. So means that A is a proper set of B. Yes. Okay. Then the other type we have number 6, power sets. Power sets. So the power set is the set of all possible. It is set of all possible subsets of a given set. It's a set of all possible subsets of a given set. Yes. Okay. So, for instance, it is given, it is expressed, let me say it is expressed as 2 raised to the power n. That's how you get a power set. It's expressed as 2 raised to the power n, where n represents the number of elements of a given set. Okay, n represents the number of elements of a given set. No, 2 raised to the power n. That is n to the power n. The n represents the number of elements of a given set. For instance, if I have a set A, for instance, set A is 1, 2, and 4. Okay? If set A is 1, 2, 4. So how many elements do we have in set A? Thank you. It means that your n is what? Is 3. Yes, so what is now the power of the set? Power of set now. Power set now will be what? Remember, it's given as what? 2 raised to the power n. Which is now 2 raised to the power 3. So 2 raised to the power 3 is written as 2 times 2 times 2 into 3 places. That is 2 raised to the power 3, meaning you have to write 2 in 3 places. So if I multiply both of them, I will have multiply 3 of that, I will have 8. So the power of this set is 8. The power of this set is 8. Understood? 8, yes. Times 2, yes. So which is now 8. Power of the set is 8. 2 times. Okay, 2 times 2 will give us what? Will give us 4. Then times 2 will give us 8. Yes. That's how we got the power. The power of the set now is 8. So if you have, for instance, if we have maybe set X is X, Y, Z, and M, for instance. How many? And I will also find the power of the sets. Power of sets. Power of sets. So how many elements are we having this time in the set? 4 elements. Means that simply means your n is what? Is 4. So the power of the set now, P of X now, power of set A now, you give us 2 raised to the power 4. You see that? Which is 2 times 2 times 2 times 2 into 4 places. Are you saying it? So what is 2 times 2 times 2? That will give us 16. So the power of the set now is 16. Yes. But you now understand how we got the 16, right? Yes. It's not 16. 2 times 2 times, yes. It's not 16. Power of the set is 16. No, you can still write it. I just jumped that. You can still write it as 2n. Your n is 4 now, which is 2 raised to the power 4. I just decided to jump that step. Yes. You can still write it as 2 raised to the power n. Elements. Yes, 2 raised to the power that number. Oh, yes, 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 yes. Okay. So this is so this is the types of sets that we have, and you need to take proper take a good note of it. Give a good note of them. It's very important. Take a good note of them. So we also have what we called equal sets. Number 7. I would call equal sets. I would call equal sets. Okay. So what is equal sets? It's when two or more sets have the same. Equal set is when two or more sets have the same elements. When two or more sets have the same elements, we call that equal sets. Okay? Yes, we call that equal sets. Okay? Like I said, you need all these concepts to actually understand when we want to start using them now. And you need them. Without all these concepts, we can actually understand sets. So if I have example now, if I have a set A as 1, 2, and 3, I have another set B as 2, 1, and 3. Do they have the same elements? So arrangement. Yes, so the arrangement does not concern us. What concerns us is that both of them have the same element. Yes, so we can say set A is equal to what? Set B. Both of them are equal. Yes, that's what we call them equal sets. So this is what I mean by equal sets. Okay? Write it. Are you there? Okay, have you written it? Okay, so we also have what we call number 8, equivalent sets. Equivalent sets, yes, equivalent sets. Equivalent sets. This is when two sets. This is when two sets have the same number of elements. They have the same number of elements, but different items, different items. Yes, that's what we call equivalent sets. They have the same number of elements, but different items. So what do we mean by that? Let's assume we have set M. Let's take set M for instance. Set M is 2, 4, and 8. Then set N is X, Y, and Z, for instance. So how many elements are in set M? How many elements are in set N? are the items is the same? Do they have the same items? But number of elements is the same, right? That's what we call them. So equivalent elements. So M is equivalent to N. Both of them are equivalent because they have the same number of elements but different items. Yes, that's the number of elements but different items. That's what we call them equivalent elements. Okay. So we also have number 9. We have a disjoint set. Disjoint set. Yes. So ordinarily, what do you understand by the word disjoint? Now, don't relate it to what we are doing now. Yeah, exactly. So the same thing is not different from what set means. So disjoint set is when two sets or more have no elements in common. Yes, that's what I mean by disjoint sets. So if set A, for instance, is 1, 2, 4, then set B is given to us as 3 and 5. Do they have anything in common? Don't have anything in common. So that's what I mean by disjoint sets. Okay. So write it. Okay. I'm coming. A minute, please. So we also have single sets. Also have a single set. Okay. So one is also have a single set. That is number 10. It should be single set. That single set is it has another name of some people call it Singleton set. I know how you want to call it. Singleton. So we call it Singleton set. Singleton. It's derived from the word single. It's when a set has one element. It's when a set has one element. For instance, set X, maybe you just have 2. So this one means by single sets or singleton set. That's what I mean by set. Yeah, just a single element in it. That's what we call single set. Yes. So these are the types of sets we can take. But if there's more, I will let you know. If there's more. But for now, these are the single. These are the type of set we can take. Okay. Then we also have set operations. This is where you need to give, although all the class give you 100% attention, but in this area you need to give 101% attention. Where we are going to now. Operations, yes, operation in sets. Let me say operations in sets. Operations in sets. So There are various operations in set. In fact, most of the things you'll be doing are based on operations. Whatever answer you have in the operation, they might ask you what type of set is that. That's why we did type of set first. So you might solve and have a particular answer. The person might ask you what type of set is this. But it's the operation that will give you the particular type of set. Okay? So the first operation we have is we call it a union. Union. This is the symbol for union. It's like a U. This is symbol for union. So remember I told you something earlier that we might see something later. Look at it here. I told you we might see this thing. But can you tell me, look at it. This one is for the universal set. You can see the difference. Can you see the difference between the universal set and the union? Yes. What is the difference? Yes. Yes. So you don't mistake both of them as the same. They are different. Yes. So what is union of sets? Normally, union means two people or more people coming together. That's what I mean by union. It's commonly used in marriage. When two people come together, it's what we call union. Right? So the union of two sets. So what the union? So the union, right? The union. Yes, the union of two sets. Is the combination. Look at the word. Is the combination. Is the combination of all elements. Of all elements from both sets, without repetition or duplication. That's what I mean by union. Yes, all elements from both sets, without repetition or duplication. So, example, if I should, so this one means you can write it A union B. You see it? That is A union B. So if you want to, if you ask you to pronounce this thing now, you pronounce it as A union B. B, yes, A union B. You see it? A union B. So yes, I told you this is symbol for union, right? This is symbol for union. This is A union B. Okay, yes. So let's take for instance, if I have set A, remember we said earlier, set is already represented in capital letter. Set A is 1, 2, 3. Then they gave us set B as 3, 4, and 5, for instance. Okay? They're not asking us to find A union B. Remember, union means you combine the two elements, but you don't have to repeat anyone. Okay? So let us combine them now. If you are combining them, you start from the least number. Who is the least number here, or the smallest number? We'll start with 1. I want to combine all the elements in A and B now. After 1, what do I see next? I will see 2 next. After 2, what do I see next? Is 3. No, 3. You don't have to say, that's why I say don't repeat anyone. So it is wrong for me to write 3, 3. It's wrong. You see, combine all the elements without repetition. So now that we have 2, 3 there, you just take a single 3. Yes. That's why I say combine them without repetition. Then we have 4. Yes, we have 4. And yes, so this is now your A. Yes, this is now your A union B. And this is now your A union B. You understand it now? Okay, let me give you one to try and tell me what the answer is. If they give you set X as set S is 2, 4, 6, and set Y is given to us as 2, 3, 5. What is now X union Y? Tell me what you have as Y. Exactly. Although we have 2, 2 there, you don't go and write 2, 2. But you just pick one, yes, to give you your A union, so your X union Y. Yes. So the answer to this will just be 2, 3, 4, 5, and 6. Is it not? So that's X union Y. So let's look at another type of operation we have. Is intersection. Second operation we have is intersection. This is symbol for it. This symbol for it. It's like N. That is symbol for intersection. Let me rewrite it for clarity purpose, just like this. A smooth N, that is intersection. So what does it mean when you say intersection? The intersection of two sets. The intersection of two sets. Okay. Consists of only the elements common to both sets. Only the elements common to both sets. That's what I mean by intersection. Only the elements common to both sets. So let's take for instance, and that you can see the symbol for intersection, right? Yes. So if I should write A and B, how will you pronounce this? How will you pronounce it? No. A. What does that symbol represent? That symbol we just wrote now. Yes. So pronounce it now. Pronounce everything together. How will you pronounce it? No, you can. A intersection B. Yes. Intersection B. Yes. A intersection B. Yes. A intersection B. A intersection B. That's how you pronounce it. Yes. So if I should have this, for instance, how will you pronounce this one? Yes, X intersection Y. X intersection Y. So let's take, so it say what is, it say consists of only the elements that is common. It consists of only the element that is common to both sets. What is common to both sets? Yes. So let's take example, for instance. If I should have example, for instance, if you should have set X as 2, 4, and 6, then we now have set Y as 3, 5, and 6. We now ask you to find X intersection Y. Let's say we can now have X intersection Y. Okay. So, like I said, intersection is looking for what is common between the two or more sets, right? So let's check the two sets. The first set says set X is 2, 4, and 6. Then Y is 3, 5, 6. So can you tell me what they have in common? So we can conclude that our X intersection Y is just what? Is 6. So what kind of set is this? A set that have one element in it is called what? Elements. A set that just have one element is what? No. If a set has just one element, what is that set called? Under the type of set. If a set has just one element, it's called what? Check the type of set that we have. Under the type of set, check towards the end. We said something about a set that has one element. Check it. No, under the type of set that we've done types of set now, right? Check towards the last parts of the type of set. We mentioned about 10. So check which of them has one element. Set. Singleton set. No, it's singleton set. Set. That's what I mean by. You can see it has only one element now. So they can ask you now what type of set is this? You just say it's a singleton solution session, and they cannot ask you. No, it's only when you are asked. It's only when you are asked. Yes. Yeah, it's singleton set because it's just one element, right? Element, yes. They can ask you a question like that. Yes, okay. So write it. Okay. Have you written it? Okay. Let's try something else. Let's assume we have set A. Let's assume we have set A, for instance. Let's assume we have set A as 2, 4, and 6. Ademola Tijani, if you can mute your mic. Somebody just join us, madam. Yes, Ademola Tijani. That is his name. And if you can hear us, you are welcome to the class. If you can hear us, you are welcome. Yes, all right. So my name is Kennedy. I'll be the one to be taking you this Maths 101 for lectures. And we have Mrs. Alima Mohammed. We have been doing the class almost over an hour now, if I'm not mistaken. And we are almost rounding up. But if you can be consistent, we'll be doing it like this. I will teach you the course all through before you write. When you date your exams, you can do revisions and the rest. Yes. Okay. So we have this. Our actually our channel is STEMUpAfrica. We create science courses, both statistics, physics, chemistry, maths, further maths, technical drawing, AutoCAD, and computer science courses. Those are things we do here. Yes. So we are actually creating the first topic in your lecture material, which is set theory, and we've done a lot of concepts about it. Maybe later we can send you the link so you go through it and see what we have done. It's very interesting. Yes. So we are currently in intersection, which is a type of set operation. So this is the second example we are taking now. Okay. So just follow through. All right. So let's continue. So let's assume we have set A as this, and we have set B. Set B is now 1, 3, and 5. We are now asked to find A intersection B. So remember what we said about intersection. Intersection means what is common between, which element is common between both sets, right? Okay. So look at these two sets now. What is common between them? What is common? So that means there will be no element inside, right? So if a set does not have any element, what is that set called? Yes. And it is called what? Yes. On that type, or the type of set we also did. We have a set that doesn't have. It's called. So this particular set is what? Is an empty set. Yes, or you can also call it non-set. Or the symbol for it again is this. Yes. So in an objective text, which is what you are doing, you might see it in this form, or you might see it in this form as your empty set. Yes. So a typical set like this is what we call the empty set. When there's no element in common, we call it an empty set. So this is a typical example now. So our A intersection B now, there doesn't have anything in common. Therefore, it is an empty set. Yes. Is it understood? You understood this one, right? Okay. So we're going to look at. Okay, so what we are going to do, based on what we have done so far, maybe should I give you some practice questions to try? Okay, let me give you some practice question, and based on what we have done so far. Okay, now just give me a minute. Let me sort out. Maybe a set of some set questions. I will write them on the board. Then you just tell me what the answer. Just tell me what the answer is. Okay. Yes. Hold on a minute. So let's take the first one. Let's say. They gave us set A, for instance. Set A is 2, 3, 5, and 7, and we're given set B as 1, 3, 5, 7, 9, and we are given set C as 4. If you say C as 4, 6, 8, and 10. Okay? So we are asked, say find question 1, A union B. Question 2, A intersection C. Question 3, we have A, B intersection C. So, Ademola, Tijani, let me explain to you what is meant by union. Union means you combine all the elements in a set together, but you don't have to repeat anyone twice. Intersection is what is common between two or more elements. It's what we call intersection. So you can just try it out. So, Madam Alima, you can solve these 3 questions. Yes. Stands for union. I believe what union means ordinarily means when people come together. It's what we call union. This symbol here means intersection. Intersection means what is common between two things. So those that is common, those are the things to write down. If it's not common, that means you are not writing anything down. So if it's not common, that means you are not writing anything down. So union is combine two elements together. So those things you see there, 2, 5, 2, 3, 5, and 7, those are what we call the elements.
What is this? You set up a wrong thing.
Hello, sorry, my network was disturbing. So I want you to recall your answer again. What is your A in your B? Okay. No. Don't duplicate any number. You don't duplicate any number. Anytime you are using union, you don't duplicate any number. Mr. Godwin Agaji, welcome to the class. We are doing Maths 101, and we are doing set theory, which is the first topic in your course material. And we explain some concepts. Maybe at the end of the meeting, I will send you the meeting lecture, the lecture, then you can go through it. But we are running out of time. So, Mrs. Alima, I told you union, you combine these elements, but you don't duplicate or repeat anyone. That's what we agreed. You don't duplicate or repeat anyone. No, there's no 4. We don't have 4 in the set. We don't have 4 in the set. A union B, yes. Start it all over. I didn't hear the first part you mentioned. That is A union B. So you combine the 2 elements, but don't duplicate or repeat anyone. So instead of three, we have 3 3 there, but don't say 3 3. We have 5 5, don't say 5 5, just write only one of them. We have 7 7, don't say 7 7, just write 9. That is union. Yes, that's how you find union. But then question 2 says you find A intersection C. C, yes. So a non-set or an empty set Then what about the last one? B intersection C. It's also an empty set. Why? They don't have anything in common, right? Yes, that will make it an empty set. Yes. So this is the that is not all yet. We still have a lot of things to cover under the set. We cannot finish the whole thing today. Okay. So if you are willing, then next time you can make contact, and you can join. Then it's not restricted to only maths. If you are doing physics courses, chemistry courses, and other area computer courses and rest, we treat them also. And computer courses, we treat them also. So anyone you're interested in, just let us know. I say these classes are not restricted to maths alone. We treat physics, chemistry, all the science courses, and computer courses also, and JST. We do all those things also. If you want, if you are interested, just contact us, and we set up the class, and we do as we always do. Okay. Okay. So I just communicate with her, and I hope you enjoyed today's class. Okay. No. So that is why we leave room for. Go ahead. No, yes, I understand. And that's why I'm taking my time to break them down for you, so you understand everything. Yes. All right. So you are. Yeah. Oh, okay. All right. So somebody will talk to you now. Okay, my partner will talk to you. All right.
Okay. Hello. Yes. So how was it? Okay.
Yes, it's very understandable.
Okay. All right.
Very simple.
Okay. Yes.
Yes, we'll continue with chemistry, which
Okay, okay, all right. Oh, TM is starting on. Okay, okay. Yes. Okay, okay. All right. Uh, Thanks for coming. So we'll, we'll put in our best for the course and in every all the courses too. You were here from beginning to the end, so you were the most person that must have enjoyed. I see you didn't miss anything. Others were having issues with their Zoom. That's why they joined late. So, yes. Godwin, were you able to get something? Okay, you can unmute. Okay, let me unmute you. Godwin, then one thing I want to also tell you, you should learn how to use Zoom. It's very important. If you are schooling with NOUN, the platform they use for their lectures is Zoom. So please, just try to practice. You can practice among two of you and your friends, you and your family members. We can be the host, try to join the meeting, so that when your classes start fully, yes, you will not have issues joining your class. Yes, yes. Yes, I'll send you the recording of what we've done today. I tried so much to wait. I asked Kalima, she was here 10:30. Even past 10 sef, that was when you started asking about the class now. I started teaching people from that 10:30, some more than 1 hour. I was trying to show people how to do the Zoom, but at some point we just have to start because we also teach, just in case you have students in secondary school, we also we teach them too, mostly their science courses. We do yes, if you check our YouTube channel, you see many WAEC based questions that are there. WAEC solution, JAM. So we don't only do university teaching, so we also teach children in secondary school from basics, yes, from the very basics, yes. Up to me, I teach up to even master's, PhD, so everything, that's what we do. So be sure to, you are going to have I just say, not today now, the last time I did that meeting with some of you that were here, I just said, okay, but I said, okay, this time let me just come and see how the class is. You will be the one to spread the good news to your friends. So that's the thing. So you tell. she's in the group, so you can ask her question. All of us are in the group, no problem. No, so try to recommend. Oh, okay. Yeah. So try to send the link to people. Not the Zoom link. Oh, the Zoom link is one-off thing, and you just recommend her. Yes. Which group is that? Okay, 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 okay. Okay, alright. No problem. Okay. Okay, they created a group for 107 for you. Okay, okay, okay. All right, no problem. If you can, if you check our YouTube channel, you see some other things that we've done, even on this course. You can also watch them so that next time I'll try to arrange all the things on Mass 101 for you, apart from today's lecture. So you can try to go through them so that next time when we have class, you will have questions to ask. Yeah. Okay. All right. Bye bye. So talk to your friends. All right. So spread it to. All right. Have a nice day. Bye bye. Okay. Yeah. Okay. Sure. Oh, yeah. I'll send you the link. I'll send the link to you. Okay.